Welcome to NASA Edge, an inside and outside look at all things NASA. Today we're going to be talking about the Blue Origin New Shepard launch and the technology that NASA is testing during that flight. It's called SPLICE and it relates to safe and precise landing. Joining us are John Carson and David Rudishauser. Thanks guys for coming on the show.
Thank you.
You're welcome. Thanks for having us.
Awesome. Well, John, I want to start with you first, particularly about SPLICE overall. I mean, what exactly is SPLICE?
So SPLICE is an acronym. It stands for Safe and Precise Landing Integrated Capabilities Evolution, which is a very loaded term. To high level, it's developing technologies that will enable a spacecraft to touch down softly on the surface of a planet and do so both precisely and safely. So precisely means, say, half the distance of a football field, and safely means that it can touch down at a location that's not hazardous to landing, like set a footpad in a crater or land the engine nozzle on a rock, or something that basically causes a failure of the landing system.
Now, we've had success in this in the past with the Apollo program, so are we learning from what we did and bringing that technology forward?
Yes, absolutely. So in Apollo, we landed in well-lit terrain regions of the moon, and we had one of the greatest computers and sensor systems available. That's the human eye and the human mind. So now with Artemis and some of our future robotic missions, we're actually targeting landing in more hazardous regions where there isn't well-lit terrain, which can cause challenges to humans to be able to see hazards, as well as landing in areas that we don't have good maps ahead of time to help aid the systems in figuring out where they are and where to land. So we're absolutely learning from that. When we have active sensing technologies using lasers, we can actually get information that the human eye has difficulty obtaining and then process that in a computer to give situational awareness that otherwise we wouldn't have had during Apollo.
That's awesome, and I get really excited when I hear about lasers and all the cool technology that's actually being developed. So I'm wondering, David, can you tell us a little bit about the specific technology you're working on to make sure we can make that safe and precise landing?
I work on the Descent and Landing Computer, which is a multi-core computer that ties all the SPLICE technology together because it provides the platform that all the algorithms execute on to process the data from the new sensor technologies that we're developing, and the new algorithms themselves are tested on this platform. So we really get all the data to come together in the DLC, which requires a multi-core platform because a lot of this processing is very taxing on the system, and it goes beyond what's been available in traditional space-based processors.
And just for clarification, David, I mean, a lot of this, it's a lot of processing, a lot of algorithms, but it's going on when it actually deploys or it's used on a mission. All this is happening very quickly in real time to provide that safety and assurance, correct?
Absolutely. There's a lot of critical computations that are happening on short time scales to accomplish the goals of the capability.
Now, you're flying on the Blue Origin New Shepard launch. What are you actually going to be able to test in this launch and maybe future launches before we actually head back to the moon?
We're going to be testing all the SPLICE technologies with the exception of hazard detection. So we'll be testing some precision navigation algorithms. We'll be testing some precision sensing systems. We'll be testing the compute element itself because this element not only is critical for SPLICE to function, but it also is a technology development in itself, because the agency is moving toward using multi-core processing systems because of the capabilities that we're demanding for planetary exploration are really becoming too complex for traditional space-based computing systems to handle. So this is a multi-core system in the DLC that we're employing, and it's actually a stand-in for what the agency is developing, the high-performance space computer, which will be available in a number of years. But we have a commercial chip that is a surrogate to the HPSC because its architecture is very similar. So that allows us to try this architecture out and get some early experience with it in preparation for future missions that will use the HPSC.
That's kind of a really amazing thought, that the technology you're developing now not only will help us get the first woman and next man back to the moon, but also potentially on other bodies in our solar system. John, start with you, and I want to hear from both of you on this. Just tell me a little bit about what that means for you personally, because this is kind of a unique process you're going through, and it's certainly part of NASA's big vision.
Yeah, well, so one of NASA's prime visions is to discover and expand knowledge for the benefit of humanity. And, you know, I'm an explorer as well. I'm a scientist, an engineer, a technologist, and getting to work on things that are going to enable us to land on different solid bodies throughout the solar system is very exciting to me. You know, this test is very exciting to me because it's the culmination of a lot of the terrestrial development that we've been doing, and it's the bridge that enables us to take this then to spaceflight. So, you know, we've been developing these technologies for well over a decade with, you know, missions like Artemis and other robotic landers elsewhere as sort of the pinnacle of why we're doing this. So I'm very excited about this, and, you know, very excited to see the integrated system get to fly on Blue Origin soon, and you know, hopefully again in the future with even more components that we're still working on. So we hope to fly those on Blue Origin, then eventually on commercial lunar missions leading up to Artemis.
And I share John's excitement. I've been interested in aeronautics and technology and NASA my whole life, like probably most of us that work for the agency. To be on this frontier of technology development and also frontier of exploration, because these systems are used for, you know, the landing on other worlds. It's very exciting to see it all come together, and it's really a privilege, and very thankful to be in the middle of it. To see this actually land on the moon at some point in the near future is going to be very exciting.
Speaking of excitement, it's great to have you guys on the show, to hear about your technology, and most of all, see how NASA is actually getting ready for this next big step to get back to the moon and hopefully onto Mars and other surfaces, as John said. Thanks so much for coming on, guys.
Thank you.
You're welcome.
Pleasure to be here.
You're watching NASA Edge, an inside and outside look at all things NASA.